Hello, um, welcome to A-Level Maths. Today we'll be looking at radians from the beginning of Pure Maths Year 2. As always, let's start off with what the definition is. So first off, we can use degrees to measure angles. So at GCSE, we would have learnt that around a point there's 360 degrees. So if you have a circle, 360 degrees, there's no real sort of an arbitrary number. It's only 360 degrees because of several reasons, like it's easily divisible by 90. It's just a good round number. But today we'll be looking at radians, which are another way we can measure angles, which is more commonly used in more sort of advanced mathematics, and that's what we're going to be learning out today. So what is a radian? So where we have one radius here, and the arc length is the same as the radius, okay? The angle made in that sector is 1 radian, okay? Now, going back to GCSE, just for a quick little detour, we know that the circumference of a circle is pi times the diameter, or since the radius is half the diameter, it's 2 pi r. Now, how can we prove this? Well, we know that 2 pi is roughly equal to, so if we know that pi is 3.14, 2 pi would roughly be equal to 6.28, or around that number. So what can we do? Well, we can take this piece of string that we have here, and we can sort of wrap it around the circle, okay? It's not exactly quite as neat as I'd hope it to be, but we can see that this essentially is our circumference of the circle, and each of these is equivalent to the radius of the circle, okay? Now, if we put our circumference here and line it up with our radius, okay, we can see that it's 1, 2, 3, 4, 5, 6, and a little bit, which is our 0.28. So it's 6.28 of our radius. In other words, this is 2 pi r, or in other words, it's our circumference. Okay, so now that we've shown that the circumference of a circle is 2 pi r, the reasoning for how mathematicians got the exact value for pi is something that maybe can be covered in a later video, but for today we'll just show that the circumference of a circle is 2 pi r. Now, when we have a radian, what we're essentially doing is we're taking a radius like this. This is 1 radius, and we're taking this radius, and if we get a pen, and if we get a ruler, what we can do is we can draw a line from where this radius starts. So this radius starts here, okay, and if we bend it around the circle, it ends about here, okay? And if we draw a line from here to the radius, from here to the center, okay, and then if we do another radius, okay, so you curve this radius around the circle, we draw a point here, okay, we do that, and we draw another radius. This is all going to make sense in a minute. We draw another radius, we get the point here, we do that, get another radius. Okay, we draw a point where it ends. Okay, so we do that. We get another radius. Draw it like this. Okay, so we draw it where it ends. Okay, so quite approximate. And then we get our last radius here. Draw where it ends. Okay, and we draw a line. Now, what we have here is basically what happened when we lined these all up and we had a little bit of string at the end. If you want to go back in the video, we'll remember that there was a little bit of the string that was left back here. This is essentially that length, okay? So now that we've got the circumference of our circle, 2 pi r, we've mapped it out on the circle. Well, what do we notice? We notice that each of these angles is 1 radian, okay? So that's 1 radian. That's 1 radian. Okay, that's 1 radian. That's 1 radian. This is 1 radian. This is 1 radian. And this is approximately 0.28 radians. Okay, so what we can see is that if we equate this all to 360 degrees, we see that roughly 6.28 radians is equal to 360 degrees. Or, in other words, if we were to get an exact value, 2 pi radians is equal to 360 degrees, right? Because we've stated how if the circumference is 2 pi r, well, and then we've mapped out the angles between each of the radiuses, okay, we can see that 2 pi radians is 360 degrees. Okay, so from this we can say that pi radians equals to 180 degrees. And similarly, you're going to want to write down all these want to write down all these values for converting degrees into radians. Okay, and so from this we can then write to get from radians to degrees. Well, what do? We times by 180 over pi, right? Because let's say if we have okay, so if we had, say, 1 radian, okay, 1 radian would be, if we had 1 radian, okay, so pi times by 1 radian equals to 180 degrees. Okay, that means that 1 radian equals to 180 over pi, right? So to get from radians to degrees, we times by 180 over pi, and then to get from degrees to radians, we times by pi over 180. Okay, so let's just write this all out. So from degrees to radians, we times by pi over 180. Okay, and there's 2 other small bits of information we're going to want to know. So if we remember back in GCSE, if we wanted to find out the length of, let's say, if we want to find out the length of this arc, right? We did the angle theta over 360 times by the circumference of the circle 2 pi r. And if we know that 2 pi radians is equal to 360, so the arc length, so if we wanted to find out the arc length, we will now do theta over 2 pi times by 2 pi r. And because 2 pi cancel out, we do r times theta, where r is the radius. Okay. Now we go on to area of a sector, similar to the arc length. We do theta over 360 times pi r squared. We know that 360 equals to 2 pi radians, so theta over 2 pi times by pi r squared. And if we simplify this equation, we'll get a half r squared times theta for the area of the sector. So that's all for today's video. I hope you found it useful, and if you have any topics you'd like to go over, put it in the comments, and thank you for watching.